A fractional part ceiling equation today. So let's take a look at how the precise definition of fractional part first here. Now what we do is we actually subtract the number, the floor of the number from the number, which makes quite a bit of sense intuitively. So right here this would be 1/5 minus 0. Okay, 1/5 minus 0. Again, the floor of 1/5 is 0, since 0 is the greatest integer less than 1/5. Okay, now what gets a little strange is this here. The fractional part of minus 4/5 is a little counterintuitive, but it makes sense if you trust this definition. So this is equal to minus 4/5. I'm just recopying this right here, minus 4/5. Now, here's where it gets fun, but it makes sense if you think about the graph of the fractional piece. It's what they call a sawtooth. So you get minus a minus 1 here. And again, folks, the floor of minus 4/5 is minus 1, because minus 1 is the greatest integer less than minus 4/5. And notice this is just equal to 1/5 also. So yes, the fractional part of a negative number is going to be a positive number. Okay. And that's a little strange, but it's consistent with the graph, and I think it's called the Graham definition. And it makes some sense if you just take a look at the graph, really, and in fact you want the result to be positive. Now this result right here, this is what we call the ceiling function, opposite of the floor function. Notice that 2 is the smallest integer that's greater than 7/5. It's kind of the dual, it is the dual of the fractional part. And right here, this also looks a little strange, but the ceiling of minus 7/5 is actually minus 1, because of course minus 7/5, it's just going in the opposite direction when you're dealing with negative numbers. It's once it's just kind of like about where it points, sort of. Okay, but minus 7/5 is certainly less than negative 1, right? Okay, now but what we can see here with both the floor and the ceiling functions, they always map to integers. In other words, in the one we're interested in today, the ceiling function, just like the floor function, is always going to be an integer. Okay. So the ceiling function, and I'll just write it like this, is always going to be a member of z. And z is just an integer, minus 1, minus 2, 0, 3, 4, etc. Okay, so the ceiling function always unconditionally maps to an integer. Now, and also the ceiling function has to be stuck. Let's just write it a little more carefully here. I'm sorry, the fractional piece has to be, no matter what your input is, let me just write it like this, less than or equal to, and I'll just use, okay, these little squigglies here, the set braces are supposed to be stand for the fractional piece, and question mark is any expression whatsoever, okay, less than 1. And just intuitively, that certainly makes sense, okay? The fractional piece is always bounded between 0 and 1. Like, for example, 7, the fractional piece of 7.2 is 0.2. And again, it's just a fraction that's less than 1. So this is always true. You got this lower bound of 0 and this upper bound of 1. Now that explains how we get this. See, because this expression on the left-hand side can be as small as 0, or it's always going to be as small as 0 or less than 1, right? So that explains this pinching part right here. This again, this piece right here is always between 0 and 1, which is going to in turn give us upper and lower bounds for this ceiling function. Okay. All right, so that's important. This statement right here implies this statement along with this, okay? All right, now, but what's good about that is that we know that since the ceiling function is always going to be an integer, and the ceiling function is trapped between minus 1/5 and 4/5, the only integer between these two numbers is 0, and that's an incredibly simplifying condition right there, okay? So that's pretty powerful to get something like that. We know for this problem that the ceiling function has to be equal to 0, which means x is in the interval minus 1 to 0. For example, just like the one we just did, you know, that it's very, very similar. It's not quite like the one we just did, but like, for example, if you had minus 0.6, okay, the smallest integer less than minus 0.6 would be 0, right? So only numbers between minus 1 and 0 are going to have a ceiling of 0, okay? Now, after this, it's fairly straightforward. The original problem, okay, notice just becomes this, okay? It just becomes this because of the aforementioned, okay? So the fractional part of x plus 1/3 becomes x plus 1/3 equals 1/5 because this is just equal to 0, right? This is just equal to 0. This piece is equal to 0. And so we get a simplified version of reality. This is our original equation. Now all we have to do is solve this. That's a big deal because it's kind of trivial, and this is related to what we talked about at the very beginning. X plus 1/3 equals 1/5 if and only if x plus 1/3 is equal to either minus 4/5 or 1/5. And again, we've already seen why that is true earlier, right? Okay, so now I didn't show every bit of the arithmetic here, but if you have x plus 1/3 is equal to minus 4/5, that implies x is equal to minus 17/5. But notice we have to reject this because you see, we can't, we have to, let me do it like this, folks, if you want to, so you can still see it. We have to reject this because it's not contained in this interval up here, right? But minus 2/15 certainly is in this interval. Okay, so I think it's kind of cool. I spent a lot of time at the beginning, but hopefully it makes a lot of sense. Maybe I've spent too much time on it. But now let's go ahead and actually check our work here, okay? Now again, folks, this is a check right here. I'm not trying to say they're equal. Let me put a question mark here just to, we're checking to see if equality is true here, right? That's what we're doing. We're taking minus 2/15. Let me get it all on the same screen. We're taking minus 2/15 and substituting it into the equation we were interested in at the beginning of the problem. Now, so let's take a look here and see if we do get equality. Now, notice, let me push up just a little bit here, folks. So you see, this would end up being, and y'all, my set braces are pathetic, aren't they? Okay, so this is minus 2/15, this is 5/15, so this would be the fractional part of 3/15, right? Okay, so that's the fractional part of 3/15, and y'all notice that is 1/5. Now we want to know, is it equal to this? Well, y'all remember the floor of minus 2/15, the next highest integer is 0, right? So we get 0 plus 1/5 here. Notice I'm not writing down equals until we've confirmed, all right? I mean, it's easy to see. I just want to make sure, okay? But notice this is true. This is 1/5, right? So this is the fractional part of 1/5. We know the fractional part of a fraction between 0 and 1 is the fraction, right? Better be, or the function is no good. So sorry. Okay, I don't know why it happens. Okay, so is equal to 1/5. And so the solution does check. Okay, here we're asserting that it's true. Definitely is true. So kind of cool. Only one unique solution. And again, this was the check that minus 2/15 is a solution, which is what we have right up here. Okay, folks, hope you enjoyed it. I like that one a lot.